Good morning to all. I am Subarani, Associate Professor in Emmanuel Research College of Pharmacy. Today's topic is Major Extracellular and Intracellular Electrolytes, Part 2. Electrolytes used for replacement therapy. To maintain the homeostasis, the concentration of electrolytes in the body. So, the electrolytes are used for replacement therapy, which is to maintain the homeostasis, concentration of electrolytes in the body. There are usually three types of solution used in the replacement therapy. First of all, sodium replacement. Second one is calcium replacement. And third one is parenteral magnesium administration. So, three types of solutions are used in replacement therapy. First one is sodium replacement. Then second one is calcium replacement. And third one is parenteral magnesium administration. First one, sodium potassium replacement. Sodium chloride, the formula of sodium chloride is NaCl, then potassium chloride KCl, compound sodium chloride solution, then oral rehydration solution ORS. So the sodium potassium replacements are used as sodium chloride, potassium chloride, compound sodium chloride solution and oral rehydration solution. Then sodium chloride preparation. So NaCl preparation. In the laboratory, it is prepared from common salt, impure salt in water by passing hydrochloric gas, acid gas. The crystals are precipitated out. So in laboratory, the sodium chloride is prepared from the common salt is dissolved in water by passing hydrochloric acid gas. So the crystals are precipitated and separated out. Okay, then second method of preparation. So in industrially preparation. In industrially, it is prepared by evaporation of seawater in shallow pans. It contains certain impurities which are removed by dissolving common salt in water and a cemented tank. Some alum, for example aluminium sulfate, and lime, hydrated limes, calcium, hydrated limes. So it's the chemical name of lime is calcium hydroxide are added. The suspension impurities get settled down easily. So in industrially, it is prepared by evaporation of the seawater in shallow pans. It contains some impurities, so it is removed by dissolving common salt in water and cemented tank. Some alums are added, for example aluminium sulfate and lime. So calcium hydroxide is added. The suspension impurities get settled down easily. Sodium chloride, this physical properties. It is colorless. It is transparent cubes or as a white crystalline powder. Sodium chloride is colorless. It is cube shape and it is white crystalline powder. It has a saline taste. The taste of sodium chloride is saline. It is slightly hygroscopy. The pH of sodium chloride is 6.7 to 7.3. It is freely soluble in water. So hygroscopy means, hygroscopy is the phenomenon of attracting and holding water molecules via either absorption or adsorption from the surrounding environment. So hygroscopy is the phenomenon of attracting and holding water molecules either absorption or adsorption from the surrounding environment. So the physical properties of sodium chloride is, it is colorless, it is transparent cubes or as a white crystalline powder, it has a saline taste, then it is slightly hygroscopic, then the pH value of sodium chloride is 6.7 to 7.3, then it is freely soluble in water. These are the physical properties of sodium chloride. The chemical properties of sodium chloride. Sodium chloride is rather easily oxidized to liberate free chlorine. So sodium chloride is easily oxidized then to liberate from chlorine. For example, heating with manganese dioxide and concentrated sulfuric acid. Sodium chloride is heated with manganese dioxide MnO2 and concentrated sulfuric acid H2SO4 and produces chlorine. So sodium chloride NaCl plus manganese dioxide MnO2 plus sulfuric acid H2SO4 to gives MnSO4 manganese sulfate and Na2SO4 sodium sulfate and water plus chlorine. So the first property is sodium chloride is easily oxidized to liberate free chlorine. For example, sodium chloride is reacted with manganese dioxide and concentrated sulfuric acid to form chlorine. Okay, then second property is sodium chloride when react with silver nitrate. Sodium chloride is reacted with silver nitrate. It gives curdy white precipitate of silver chloride. So sodium chloride, the formula of sodium chloride is NaCl, then it is reacted with silver nitrate AgNO3 to give silver chloride, a curdy precipitate of silver chloride AgCl plus sodium nitrate NaNO3. Okay, then the precipitate which is affected by light is soluble in dilute ammonia and insoluble in nitric acid. So the curdy white precipitate of silver nitrate is presented. The precipitate which is affected by light, it is soluble in dilute ammonia and insoluble in nitric acid. Okay, these are the chemical properties of sodium chloride. First property is sodium chloride is oxidized to form chlorine. Then sodium chloride is reacted with the manganese dioxide and sulfuric acid to form manganese sulfate and sodium sulfate plus water and free chlorine gas. Then sodium chloride is reacted with the silver nitrate to form silver chloride, curdy white precipitate of silver chloride and sodium nitrate. Then uses. It is used as an electrolyte replenisher. Sodium chloride is used as an electrolyte replenisher. Then it is used as emetic. It can be used in homeopathic medicine. Sodium chloride is used as an homeopathic medicine. Solution of sodium chloride may be used as an eye drop, then nostril drops, etc. and used as mouthwash. So sodium chloride is used as an electrolyte replenisher, emetic, and it can be used as an homeopathic medicine, and the solution of sodium chloride may be used as a eye drop and nostril drops, and it is used as a mouthwash. Then assay. An accurately weighed quantity is dissolved in water and a known excess of 0.1 mole of silver nitrate solution dilute HNO3 and diethyl phthalate are added. It is titrated with 0.1 molar ammonium thiocyanate solution. So an accurately weighed quantity of sample is dissolved in water and known excess of 0.1 molar silver nitrate and dilute HNO3 and diethyl phthalate solutions are added. It is titrated with 0.1 molar ammonium thiocyanate solution using ferric ammonium sulfate is, as a indicator. Then this is a modified Volgas method. Sodium chloride is precipitated as silver chloride by the addition of silver nitrate. This method is modified by Volgas method. Then sodium chloride is prepared by sodium chloride is precipitated as silver chloride by the addition of silver nitrate. So the sample sodium chloride is taken and the excess of silver nitrate and dilute HNO3 and diethyl phthalate is added. Then it is titrated with 0.1 molar ammonium thiocyanate solution. Then indicator is added. The sodium chloride is reacted with The sodium chloride is reacted with silver nitrate to produce silver chloride. Okay. The diethyl phthalate is added to coat the silver chloride so that it will not interfere with the titration of the excess silver nitrate. So diethyl phthalate is added to only coat the silver chloride so that it will not interfere the titration. The excess of silver nitrate with 0.1 molar ammonium thiocyanate, since the silver chloride silver chloride reads slowly with ammonium thiocyanate. In previously, the Indian Pharmacopoeia in 66, sodium chloride was assayed by direct titration in neutral solution of 0.1 normal silver nitrate using potassium chromate as an indicator. In normal method, then sodium chloride is assayed by direct titration with a neutral solution with the 0.1 normal silver nitrate using potassium chromate as an indicator. So, silver nitrate AgNO3 plus sodium chloride NaCl gives the precipitate silver chloride and sodium nitrate. Then the silver nitrate is reacted with ammonium thiocyanate NH4SgN gives AgCN silver thiocyanate plus NH4NO3. So the same cannot be used now since the silver chromate formed as the end point is soluble in acid. Okay. Then second method, calcium replacement. Calcium replacement method are used as the solutions. First one is calcium chemicals. First one is calcium gluconate. Then second one is calcium chloride. Third one is calcium lactate. Then fourth one is calcium livulinate. Calcium gluconate. The chemical name of calcium gluconate is, the chemical formula is HOCH2 CHOH 4 times COO twice CaH2O. The method of preparation of calcium gluconate. It is prepared by boiling a solution of gluconic acid with excess of calcium carbonate, filtering and crystallizing the substance from filtrate. So, calcium gluconate is prepared by gluconic acid is reacted with calcium carbonate. Gluconic acid is reacted with calcium carbonate and the crystal is formed. Crystallizing the substance is formed, it is filtered. Okay, then pure calcium gluconate is obtained. Then properties. It occurs as odorless. It is no smell and white crystalline powder. It is not tasteless. It is freely soluble in boiling water. It is sparingly soluble in water and insoluble in alcohol, ether and chloroform. So, the physical properties of calcium gluconate is it occurs in odorless, then white crystalline powder. It is tasteless. It is freely soluble in boiling water and sparingly soluble in water and insoluble in alcohol, ether and chloroform. Then uses. It is used as a source of calcium ion in the treatment of calcium deficiency and hypocalcemic tendency. So, the calcium gluconate is used as the source of calcium ion in the treatment of calcium deficiency and it is used as hypocalcemic tendency. Okay. Then assay of calcium gluconate. The assay is based on complexometric type. The assay of calcium gluconate is based on complexometric type titration, forming a well-defined symbol complex between calcium and disodium ethylene diamine. Calcium, this titration forming a well-defined symbol complex between calcium and disodium ethylene diamine titrated. That means EDTA. Then it is used as modern black to indicator. Modern black to as an indicator. The end point is change of color from red to blue. So the calcium and disodium EDTA are EDTA using modern black to indicator. The end point is change color from red to blue. In this assay, a solution of magnesium sulfate is added before the titration to make the end point. Then first of all, magnesium also forms a similar complex with EDTA, but this titration have to be carried out in the presence of buffer such as strong ammonium chloride solution. Calcium Ca2 plus H2O2O minus gives Ca gamma 2 minus plus 2H plus. An aqueous solution of the substance containing magnesium sulfate and a strong ammonium chloride buffer is titrated with 0.05 molar EDTA. Then using modern black to as an indicator, from the volume of 0.05 molar magnesium sulfate is subtracted, then each ml of the remainder is equivalent to the 0.02420 of calcium gluconate. Then official test of identity, it gives the reaction characteristics of calcium and to a solution of the substance in water. Ferric chloride solution is added, a yellow color is produced. So then this solution is identified as calcium gluconate. First the reactions of all the characteristics test of calcium, then the solution of the substance in water, then ferric chloride is added, a yellow color precipitate is formed. Then electrolyte combination theory, oral rehydration solution. It is given to the patient to prevent or treat mild to moderate fluid loss. It is resulted due to diarrhea or when food and liquid intake have been stopped momentarily. It provides sodium, chloride, potassium, water and other basic nutrients. The oral rehydration solution gives sodium, chloride, potassium, water and other basic nutrients. Sodium transport and water absorption are carried out by carbohydrate 2 to 2.5% of glucose present in it. So the oral rehydration solutions are given to patient to prevent or treat mild to moderate fluid loss, then resulted due to a diarrhea or when food and liquid intake have been stopped momentarily. It provides sodium, chloride, potassium, water and other basic nutrients. The sodium transport and water absorption are carried out by a carbohydrate in 2 to 2.5% glucose present in it. Then these are the ORS packets. ORS, composition of ORS. The standard 310 MOSM per liter ORS formula has been replaced by new 245 MOSM per liter. Formula of ORS as per the recommendation of World Health Organization and UNICEF. Then ORS composition, sodium chloride, potassium chloride, trisodium nitrate, glucose and water, amount 2.6 grams sodium chloride and ions Na plus ion, the concentration 75 mm. Then potassium chloride 1.5 gram, K plus ion 20 mm. Then trisodium citrate 2.5 gram, Cl minus ion, then 65 mm. Then glucose 13.5 gram, citrate, then 10 mm. Then water 1 liter, glucose 75 mm. So total osmolarity 245 MOSM per liter. Then ORS administration. Patients are suggested to drink ORS at regular intervals of half to 1 hour. In the beginning, 5 to 7.5% volume is given into every 2 to 4 hours. In a physically weak child refused to drink ORS, then it can be given through intragastric trip with an aim to restore the hydration within 6 hours. Then adverse effects: hypernatremia, hyperkalemia, acid-base disturbances occurring occasionally. The hypernatremia, increased sodium level in blood. Then hyperkalemia, increased concentration of potassium. Then third method, acid-base disturbance occurring occasionally. Then the contraindications, repeated vomiting, renal dysfunction, then shock. So the precautions, errors in rebuilding or diluting the viable powder. Parenteral replacement therapy is used to maintain electrolyte imbalances that has occurred due to fluid loss, then inability to take fluids, serves gastric distension or serves vomiting. So these are the intracellular, extracellular electrolytes and some replacement therapy. The replacement therapies are sodium, potassium, sodium replacement, calcium replacement, and a parenteral magnesium administration. First of all, sodium potassium replacement. Then example, sodium chloride is. Then calcium replacement, we will study calcium gluconate, the physical properties, chemical properties, and assay of calcium gluconate. Then electrolyte combination therapy, then ORS, oral rehydration solution, then the composition of ORS and the administration, and then next study the adverse effects, then precautions, etc. So these are the electrolytes. Intracellular and extracellular electrolytes are completed. Okay, thank you.